Here is a picture of the problem. It gets cut off in the video, so note the 1 and the 3 resistors in series on the left. Okay, so what we're doing here is solving. Our end result is just going to be a battery with 1 resistor. Right? We don't know what this is. This one's 24 volts. But we want to combine all of these and all of these to get this.
Alright. So you just want to combine all the resistors to get 1 resistor.
Correct. Just to simplify it and make it easier. So there's 2 different identifications that you have to have, a series and a parallel. So we'll start with a couple easy ones. That's a series, and that's a series. That's a series, and that's a series. Alright. So you can combine. I'm going to rewrite all this. Right. We're going to write it over there. Alright.
This one allows us to write.
So right here, we have
questions where you would be applying that. And it may, I mean, you just need a circle. Because you don't have to use the question they have.
1.
And so
if I like extend it off of this?
Plus 3.
Almost, more or less.
Theoretically, yes, but the way this circuit is drawn, it's not going to work.
And here we have.
But yes, you could have found a problem that would involve both, showing that we know the.
Is this the division stuff for us?
Yes.
2.
Well, no, that's the combination stuff. So that's 3-1.
Right, that's 3.1, and we still don't test on that.
Good.
You don't have to test on any of those, but it is.
And because they're in a series, we can just add the 2 numbers to get the result.
Alright.
Yeah, there's no expectation that you do all 5. Because ultimately you need to have 5 competencies in each of the 5 competencies. But you're going to have far more subtopics than just 5. Okay. So yeah, so fill that out and you could add to it by adding a source of a certain type or something of that sort.
Okay, now we're gonna do this side. We just combined this side, simplified it a little more. We're gonna do this side now. So.
Can I do that outside of class and then submit that still? Okay.
Yeah, you don't need to turn it in today. I'm going to show you on Friday where to upload it. If you turn it in today, I'm not going to check it. All right, yes.
Okay, we're gonna make a little bit of room. Alright, good thing to do. 1 plus 4.
Because that's the temperature. It just indicates that you'll show.
So you see how we took this side, simplified it over there?
Yep.
Since those are series, we can just add them, just like this. That's all we have to do. So this is the same thing as that.
Alright.
If you do.
Now I'm gonna simplify it more with parallels and write this, down
So
here.
yes, I can.
So we're gonna do these parallels and these parallels.
Alright.
So
I just learned like.
it's a little different than series. You can't just add them up. It's not that easy. So the equation we're gonna follow. R total.
Because I'm sure I could find someone to do it somewhere.
Yeah, most of these actually came from the.
R total equals R1 plus R2 plus R3.
Yeah, I mean, I will The problems we do in class
Mhm.
are examples of the topics.
One
I'm
over
gonna,
R
in this next
total
section, I'm gonna do
equals
more.
1 over R1
As we
plus
do it.
1 over R2.
And so that may give you, the
1
only
over
difference with the quiz
R3.
ones is that I never asked you to actually give me.
Does that make sense?
Yep.
Yeah,
Sort of
just-
set
So
it
this
up.
is what you do in a series, this is what you do in a
And so
parallel.
that might be your
Alright.
best bet. is to
These
get
are parallels.
sense for
So we're gonna
problems
take
for the ones that
1
you're
over
doing
4.
in class.
We're gonna write it
Alright.
right here.
Yep.
Is 1 over 4 plus 1 over 6. Right? It's gonna equal 6, 10 over 24. Right? That's what 1 over RT is.
Alright.
So now RT equals 24 over 10.
I actually.
Just flip them.
Flip 'em, yep.
So when you rewrite this into one resistor, it's going to be 2.4 ohms. These two combine into that.
Alright.
This resistor here.
I'm just glad the company chairs are the first ones.
So this one rewritten right here. And this one rewritten right here. So now we just combine these two right there.
Yep.
We're going to combine these two right here. So same thing applies. It's going to be 1 over 5 plus 1 over 5. 2 over 5, which equals 1 over the total. And we're looking for the total. So we have to take the reciprocal.
Alright.
So these two equal that. So now we have a third system. So these are easier. These are series now, so we can just add them straight up.
Alright.
So we're going to end up, we're going to start with these two. 0.6 ohms plus 2.4 ohms equals 3 ohms. So we make that into one resistor. Three ohms. Those two into that one.
Yep.
And then 2.5 ohms plus 0.5 ohms equals 3 ohms. And those two. And this is 24 volts. So now we're left with this simple thing, but we want to make it into this, right? There's two more. So this is just, it's not, I mean, we could write these lines as big as we want. We could write them in we could, they don't have to be straight. I mean, we have the freedom to write this system however we want.
Yep.
So I'm just going to flip these. It's going to be the same thing. So right? So this one's 3 ohms, that's right there.
Yep.
That's right there. and this is right there. Now you can see that this is a parallel, right? And we can do stuff with a parallel. So, I guess we're gonna rewrite it right here. So like before, using this equation, for these two variables, we can do 1 over 3 plus 1 over 3, right, those two?
Yep.
Equals 2 over 3 ohms. Right, that is 1 over RT. And we're looking for RT, so we're going to take the reciprocal. And that is our answer. Right there. Perfect.
So.
Good?
Yeah, I'm good.
Okay, say hi to the camera.
Morning.